task set to us by the UQ Composites group was to investigate the acoustic performance of biocomposites, specifically carbon fiber. To do this, we were instructed to design and manufacture a carbon fiber musical instrument. An acoustic guitar was selected as it would be extremely capable of demonstrating acoustic properties. Such projects have obviously been done before. However, the key difference within our project will be the implementation of aerospace-grade carbon fiber as well as aerospace manufacturing techniques.
So I'm Luigi Vandi, a postdoc in the UQ Composites group, which is led by Martin Veit. And I'm here pretty much in charge of the composites lab in manufacturing. In the group, we do a lot of research in manufacturing of composite materials with a focus on aerospace materials and a few projects on rapid assembly. There's also several projects on natural fiber and biocomposites. And at last, we do a lot of research in health monitoring, so non-destructive testing and acoustic properties of composite materials. Basically, composite materials have changed their use primarily from aircrafts, then it's going more and more into the automotive industry, and now you're starting to see it in musical instruments a lot.
I'm Martin Veit. I'm a teaching and research academic at the University of Queensland Mechanical and Mining Engineering School, and I'm leading and representing UQ Composites. So, and we do research in different areas. So the themes we do are biocomposites, so that's one theme. The other one is manufacturing and assembly, and the third one is sustainment, which includes also damage detection and micromechanical modeling. So composite materials have some interesting properties and also in acoustics. So for example, biocomposites are very attractive these days for dampening behavior, so in architectural and civil engineering applications. But we are also interested in using these materials or investigating these materials in regards of their performance for instruments. So that's where the motivation came from for this particular project.
As both project supervisors briefly outlined, the core project objective is to manufacture a functional acoustic guitar. It must be constructed from an aerospace-grade carbon fiber and assembled using aerospace composite manufacturing procedures. Additionally, the group has decided to incorporate several other factors that they believe will enhance the guitar. The acoustic and material properties will be of high industry standard, the guitar's design will be unique whilst abiding by the manufacturing parameters, and finally, external sourcing of additional parts, such as the fretboard and tuning pegs, will produce a high-quality final product. In light of the time constraints, the objective is intended to be achieved by following the outlined project structure. An initial design overview, including the overall guitar shape and dimensions, will be developed. Afterwards, the CAD model of the design will be finalized in order to produce a mold for manufacturing. Simultaneous to these, structural and acoustic vibration tests will be undertaken on the intended material specifications. An evaluation process is then required to further develop the design parameters and manufacturing procedure. The first build will then commence, wherein a product will begin to be physically constructed. An assessment of the final product will finish off the project, with any successes or failures being observed and recorded in terms of overall guitar performance.
Hi, I'm Kane. I'm the Chief Design Engineer for the project and I'm also in charge of safety. In terms of the design of the acoustic guitar, I'll be in charge of all computer-aided modelling and simulation. Additionally, I'll work with the other team members to ensure the design meets the requirements of acoustic and structural performance, as well as the client requirements. As most of the project will be conducted in the UQ Composites laboratory, there are certain safety procedures to follow, and it is my responsibility within the team to make sure that these safe work procedures are being adhered to, whether it be by ensuring appropriate precautions are taken while using dangerous equipment, or by making sure material safety data sheets are available. As per the university's guidelines, it is also important that risk assessment procedures are followed.
Hey, my name's Luke Donaldson and I'm in charge of composite properties and lamination theory. As the selection of a specific carbon fiber grade was already outlined within our project definition, it will be my job to research all lamination theories relevant to our project. The carbon fibre grade we will be using is known commercially as HexPly M18 and is available within our lab in two forms, unidirectional and 4-harness satin weave. The weave pattern available to us is a 4-harness satin weave, wherein the horizontal fibres will run across 3 vertical fibres before weaving underneath the 4th. This particular weave style enhances the material's ability to be shaped and will be primarily used within our project. The second prepreg available to us is the unidirectional ply, wherein every fibre is oriented in a single direction. These fabrics will be laid in varying directions in order to enhance the laminate's mechanical properties, specifically in the direction of any expected stresses. I will therefore conduct numerous calculations into the benefits of each layering format while trying to minimize the overall weight of the guitar. Finally, it will be my job to conduct ongoing mechanical tests upon various laminate samples to gain an understanding for what stresses the material will be capable of withstanding.
Hi, I'm Gawen Zhou. I'm in charge of manufacturing process. Our main idea of this project is to create a high-quality carbon fiber acoustic guitar. Therefore, every manufacturing step should be taken carefully. Resin dispenser is one of the important manufacturing steps. Carbon fiber sheet with resin is tapped into the curves of the mold. The quantity and orientation of the carbon fiber sheet should be considered and calculated to achieve the required stiffness and strength. Also, bubbles around the edges should be removed to avoid the possible effects to the sound quality. Vacuum bagging method was selected for the curing the body of the guitar. Due to mechanical property consideration, this method is to ensure the resin doesn't have any air between layers. Also, the intersections of steady tabs have to be sealed carefully to avoid air leakage. Finally, the entire body is baked in the oven for 1 to 2 hours with 180 degrees Celsius.
Hi, I'm Michael, and my role is focused on the acoustics and vibrations of composites. It is my responsibility to overlook the acoustic research, analysis and tests performed for the project. The vibrational behaviour of the guitar's material and soundboard largely influence its overall tone. In essence, a guitar's tone is the result of a summation of overtones, which are affected by the acoustics and modal parameters of the guitar. This includes the guitar's resonances, mode shapes, damping and acoustics. To analyse these parameters, the team is going to be conducting a combination of accelerometer and vibrometer tests. We'll examine how the fibre or stiffness bias in one direction can affect the general response and aim to predict how this ties in with the guitar tone. Furthermore, there will be a focus on the effect of stiffeners. Traditionally, these have solely been used as a structural purpose. However, there is now thought to be an acoustic advantage to their implementation, and so we plan to explore the influence these stiffeners have on the vibration response of the guitar. By completing this project, the team intends to have identified a manufacturing technique able to produce an aerospace-grade composite acoustic guitar. Throughout the project, we'll be investigating the vibrational and acoustic behaviour of the composite material and provide a link with the effect this has in a musical application. Finally, we will assess the completed product by evaluating both the practicality in the construction technique and the overall guitar's performance.